Good afternoon to every one of us. It's good to be back here right now. Like I said in our last class, we're going to be discussing work, energy, and power. What is work? Work is simply defined as the ability of a force to move an object. So when you move an object in a direction with a certain level of force, you are doing work. That's the simplest definition for work. So, an important rule you must know that if there is no force, there cannot be movement, and no work can be done. So, for work to be done, there must be force, and this force must cause a movement. That's when work is done. Let's look at these examples. Pushing a box and it moves, then work is done. Pushing a wall and it doesn't move, we all know it is impossible for us to push a wall. And as long as the force we have applied on that wall does not cause it to move, then no work is done. So, work is simply defined as the ability to apply a force to an object, to a body, to cause it to move. Remember, it is a vector quantity because it consists of two or more formulas that will derive it. So what is the formula for calculating work? The formula for calculating work is force multiplied by distance. Force multiplied by distance. So for work to be done, there must be a certain level of force that causes a movement. The symbol for work is W, and the SI unit for work is joule. So if force is 1 Newton and the object moves in a direction of 1 meter, then 1 joule of work is done. 1 joule of work is done. 1 joule of work is done. So the SI unit for work is joule. Remember that for work to be done, there must be a certain level of force which moves an object or a body. Let's look at some practice questions on work. A force of 10 Newton is used to push a box through a distance of 5 meters on a smooth horizontal floor. The work done by the force is, recall that we have to look at the criteria, the variables stated in the question. So we have a force of 10 newtons, we have a distance of 5 meters. Then work can be done. If the force of 10 newtons is applied in a distance of 5 meters, then work must be done. That means that box has moved through a distance of 5 meters, work is done. So the formula for work is force times distance. And we have the force to be what? 10 newtons, and the distance to be what? 5 meters, which equals to 50 joules. Let's look at another question. A boy carries a load on his head and walks 20 meters along a level of a road at constant speed. The work done by the boy on the load is, let's read this question again, very technical. A boy carries a load on his head, meaning the boy is not applying any force in line with the direction. He's carrying a load on his head. it is not in the direction of that load. So no force is actually applied on the load. If the question states that a boy pushed a load in a direction of 20 meters, then we can now say work is done. So on this particular question, the force being applied on that load is vertical, not perpendicular in direction of the load. Not direction of the load. So the work done by the boy is force is 0 newtons, distance is 20 meters, and work is what? It will now be force times distance, knowing fully well that force is 0 newtons. The work done will be 0. For work to be done, let's read the solution very well. For work to be done, there must be a force on the load direction. In this case, there is no force on the load. It has not pushed that load in that direction of 20 meters. Another question. A force of 20 newtons pulls a body through a distance of 15 meters at an angle of 60 degrees to the direction of the motion. Calculate the work done. Here, the parameters given is force, 20 newtons, distance at 10 meters, and there's an angle between the force and the direction of the motion stating, which is known as 60 degrees. Work is actually done, but then you must convert the force to be in perpendicular with the direction of the body. Yes, the body is pulled with a force of 20 newtons in a distance of 15 meters. Established. Work has to be done, but it is at an angle. So for you to get the correct answer, you are going to use cosine of 60 degrees. So for work to be done, only horizontal component of the force does the work, not at the angle. So therefore, work equals force times distance that times cos 60. So when you see questions like this that says at an angle, please quickly take note that whatever angle was given to you, you are going to apply a cosine to it. So, and we have the answers to be force of 20 newtons multiplied by 15 meters, and cosine of 60 is 0.5, which equals 150 joules. Energy is a step-by-step thing. Energy is the ability to do work. For work to be done, there must be a force pushing a body and object in a certain direction. Now, the ability to now do that work is called energy. So if you can walk, you have energy. Example, a car has an energy. A moving car has an energy. Food gives us energy. A raised stone has an energy. So for work to be done, we know there is going to be a certain amount of force perpendicular in the direction of that force. Now, the ability to now do work is called energy. What are the types of energy? We have the kinetic energy, which is energy of motion. Energy of motion, that a body is moving. The energy that comes into play when a body is in movement is called kinetic energy, and it is defined as half mass times velocity squared, where mass is m and velocity is v. So a moving bicycle has kinetic energy because the vehicle is moving, it has kinetic energy. If an object is not moving, its kinetic energy is 0. As long as the object is not moving, the kinetic energy is 0. So if you see a question where the object is not moving and you ask for the kinetic energy is 0. The object is not moving. So let's look at some practice questions on kinetic energy, energy of movement. A body of mass 2 kg is moving with a speed of 5 meters per second. What is the kinetic energy? Solution. Kinetic energy equals half mass times velocity square. Unit of energy is joule. Let's look at the parameters given in this question. Mass of 2 kg, velocity of 5 meters per second. We are now going to apply it. Half, which is 0.5, multiply by the mass, which is 2, multiply by v square, which is 5 times 5. And we are now having 25 joules. So the kinetic energy for this question is 25 joules. Let's look at another question. The speed of a moving body is doubled. How does this affect kinetic energy change? There is a moving body, the speed is doubled. There is a moving body and the speed is doubled. So our kinetic energy we know is half times mass times velocity squared. But we must take note that for the kinetic energy to increase, it is directly proportional to velocity. As the velocity of, velocity is a speed in a direction. So meaning it is a vector quantity because it has size and direction. So for the kinetic energy to increase, then the speed or velocity must have increased. In this question, it is stated that the moving body, the speed is increased by 2. How does this affect the kinetic energy change? So the kinetic energy is not stated, but we are assuming that the velocity is v. Now the velocity is doubled, meaning 2v. So by now saying kinetic energy is directly proportional to velocity, if we equate it, kinetic energy equals 2v squared. And the answer gives us 4v squared. So the kinetic energy becomes double. 4 times. So many students will wrongly choose double instead of 4 times. So in order to get this question correctly, you can quickly assume and give the velocity a certain figure. So it makes that simpler for you. If the speed of the moving body is now halved, now the speed is reduced by half, that will now be v divided by 2. And that means the kinetic energy will reduce 4 times. Take note, kinetic energy is directly proportional to velocity. Let's look at another practice question. 2 bodies, A and B, have the same kinetic energy. Body A has mass m and speed v. Body B has mass 4m. What is the speed of body B? This question very technical. There are 2 bodies, they have the same kinetic energy. And it is stated that body A has a mass of m and a speed of v. And body B has 4 times mass of body A. For you to get this question right, the solution states that kinetic energy is half times mass velocity squared, where bodies A and B has the same kinetic energy, with body A having a mass of m and speed of v. So you need to equate. An assumption is that both of them has the same kinetic energy of 50 joules equals 50 joules. So you need to equate it together. And that's what we have done. But you must take note of the fact that the body B has 4 times mass of A. So let's assume that the speed of body B is y, for clarity's sake. Kinetic energy is half times mass times velocity squared. That is the kinetic energy for A. And the kinetic energy for B is half, which is 0.5, multiplied by the mass, which is 4 n, multiplied by the speed we have now assumed, which is y squared. When you solve this mathematically, we find out that v squared equals 4y squared. And y, which is now the speed of B, will be VO divided by 4. So for you to get this question, you need to equate, because they said they have the same kinetic energy. You need to equate them together. Give B a value, the speed a value, and solve mathematically. What is the other type of energy? The other type of energy is called potential energy. Potential energy is stored energy when there is no movement. And one popular one is the gravitational potential energy. This is the energy of height. Yes. Gravitational potential energy and energy of height. It is calculated as potential energy equals mass times gravity times height, where mass is m, gravity, acceleration due to gravity is 10 meters per second square for UTME, and height equals h. In some cases, it might be specified that the acceleration due to gravity is 9.8 meters per second square. Just look at your question very well. Don't assume whatever you are given as the figure of G is what you should use. So when a stone is on a building, on the top of the building, that is gravitational potential energy. It is not moving. It is the energy of height. You are expected to calculate the potential energy. Let's look at some questions and solve together. Practice questions on potential energy. A body of mass 2 kg is raised vertically to a height of 5 meters. This is gravitational potential energy above the ground. If G is 10 meters per second square, calculate the gravitational potential energy gain. Recall that potential energy equals mass times gravity times height. What are the parameters supplied in this question? We have mass of 2 kg, we have height of 5 meters, and G 10 meters per second square. So by inserting into the equation where the mass is 2 kg, the acceleration due to gravity 10 meters, and the height is 5 meters, we are going to have the potential energy of 100 joules. Let's look at another technical question. 2 stones, P and Q, have masses 2 kg and 4 kg respectively. They are raised to the same height above the ground. Which of the following statement is correct? 2 stones raised to the same height, that is gravitational potential energy, but they have different masses. So for gravitational potential energy, what you must consider is height. And since they are having the same height, we want to find out which of the statement is correct. P has a potential energy than Q. No, the mass is smaller. It cannot. Q has a greater potential energy than P. Yes, because the mass of Q is greater times 2 of P. Both can never have equal potential energy. Their potential energy depends on their speed. No, you are now talking about kinetic energy there, because before speed can happen, that means they must be in motion. So the correct answer is Q has potential energy than P, meaning that potential energy is directly proportional to mass. As the mass continues to increase, the potential energy also increases. Let's look at another question on potential energy. A body is raised to a height h above the ground and gains potential energy, which is gravitational potential energy, very common. If it is raised to a height of 3h, what will be the new potential energy? what will be the new potential energy. So it has an initial height of h and it is raised to an height of 3h. Don't cram, just we know that the formula for potential energy is mass times gravity times height. But in this case, the potential energy has been given a variable E. So we are equating it. Equals mass times gravity times height. Now, the old height is h, the initial potential energy. Now, once the height has now been increased to 3h, definitely by adding 3h, which is the new height, therefore, the implication on the potential energy will be 3 times the potential energy. As the height increases, the potential energy increases. So the correct answer will be 3. These are some key facts that you have to take note of. In kinetic energy, it is directly proportional to the velocity. As the velocity continues to increase, the kinetic energy increases. And in terms of height, as the height increases, potential energy also increases. But for a body to have more potential energy, that means it must have more mass. That's why the potential energy is directly proportional to the mass. So let's look at the relationship between kinetic energy and potential energy. Energy can change from one form to another. Please take note of that. Energy is not lost, it's not erased. It only changes form. So if we have a stone at a certain height, which is potential energy, and the stone falls down from a building, it becomes what? Kinetic energy. A stone at a particular height falls, it becomes kinetic energy. So this further supports the fact that energy is not lost, it only changes its form. So the law of conservation of energy simply states energy can neither be created nor destroyed, but it can change from one form to another. So please take note that at a point in time, a body might execute kinetic energy and later become potential energy, or from potential energy to kinetic energy. It is the law of conservation of energy that energy can neither be created nor destroyed, but it changes from one form to another. Simple meaning to it is that energy does not disappear, it only changes form. So much for energy. Let's go into a new subtopic. We have discussed work. We have also discussed energy, which is the ability to do work. And energy has different types: kinetic energy and potential energy. The energy of movement is kinetic energy, and the energy of height is potential energy. So we're going to what is called power. Power is defined as how fast a work is done. So when you apply a force on a body in a certain direction perpendicular to it, the faster the work is now done will tell us the amount of force you have applied. So two people may do the same work, but one finishes first, but the one that finishes first has more power. That means the ones that finishes first has exerted more force to finish that job. So what is the formula for power? Power is defined as work divided by time. And recall that the SI unit of work is joule, and the SI unit of time is seconds. So you can actually say the SI unit for power is 1 joule per second, but it is more applicable to use watts, 1 watt. So let's look at some questions on power. A machine does 200 joule of work in 10 seconds. Calculate its power. Very simple. Let's look at the parameters. The parameter says that we have work of 200 joules and we have a time of 10 seconds. The power is what we need to calculate. Power equals work divided by time. In some cases, the question might not be so direct. The question might prompt you with work, giving you a force and a distance. very trickish, where they would never have told you that the work done is 200 joules. They might tell you that a machine exerts a force of 20 newtons for 10 meters in 10 seconds. Calculate its power. It is now left for you to know that work is expected to be calculated first, and work in that place will be what? Force times distance. So, but this question is direct. We know power equals work divided by time, and the power here will now be 20 watts. Another question. An electric motor lifts a load and does 600 joules of work in 30 seconds. What is the power of the motor? So, if you don't see the work and you have seen a certain amount of force in a certain distance and time, please calculate your work and now equate it into the formula for power, which is work divided by time. But in this case, it is direct. Work is 600 joules, time is 30 seconds. That means the power for this electric motor is going to be 20 watts. Let's look at another question. Power. Yes. Questions to come like this in UTME. Two machines, P and Q, do the same amount of work. Two machines, P and Q, do the same amount of work. Machine P completes the work in 5 seconds. Machine Q completes it in 10 seconds. Which of the following statement is correct? For machine P to have completed the same amount of work in 5 seconds shows that there is a certain level of force that is greater. And that's what you should look for in the answer to your question. Which of the following statement is correct? P and Q have the same power? No. Q has greater power than P? No. Because Q completed the same work at a delayed time. P has greater power than Q? Yes. Because it must have exerted a force higher than that of Q. So please take note of how to answer questions this way. We'll be talking again about, in another subtopic, mechanical advantage and efficiency. The mechanical advantage tells us how much a machine helps us, how much a machine has been able to assist us to do a certain amount of work. It is often calculated as load divided by effort. So when you see a question that has load and effort, you are being told to calculate the mechanical advantage. Now, efficiency shows us how useful a machine is. How useful a machine is. And in order to calculate efficiency, efficiency is defined as useful work divided by total work times 100%. Useful work divided by total work times 100%. Or mechanical advantage divided by velocity multiplied by 100%. Mechanical advantage divided by velocity ratio multiplied by 100%. Please take note of this formula as we intend to answer some questions. Let's look at some questions. The practice questions on mechanical advantage and efficiency. A machine has a load of 600 newtons and an effort of 150 newtons. Calculate the mechanical advantage. The mechanical advantage is defined as load divided by effort. And the load in this question is 600 newtons. The effort in this question is 150. So the mechanical advantage will be load divided by effort, which is 600 divided by 150, giving you 4. Let's look at another question. Which of the following statements about a machine with mechanical advantage greater than 1 is correct? So, for a machine to have a mechanical advantage greater than 1, something must have happened. That means there are several forces working at play. So the correct answer will be the machine multiplies force. If a mechanical advantage is greater than 1, then the machine multiplies force. Sometimes when you see questions like this, it's just to test your level of logical reasoning. They might look so difficult, but they are very cheap. For mechanical advantage to be greater than 1, it means that the machine is multiplying forces. Let's look at another question. A machine has a mechanical advantage of 4 and a velocity ratio of 5. That's the question. In this question, there is no useful work or work done. But it has been stated that the mechanical advantage is 4. It has been stated that the mechanical advantage is 4 and the velocity ratio is 5. Calculate the efficiency. Recall that efficiency is mechanical advantage divided by velocity ratio times 100. And it will give you 4 divided by 5 multiplied by 100. Please take note that mechanical advantage can never be greater than 100%. We are going to look at a question on that. It can never be greater. That is impossible. Once you see a question on the mechanical advantage, it can never be greater than 100%. Let's look at a question. Which of the following is most efficient? Yes. When they say it's efficient, you are told to calculate the efficiency. Look at how tricky this question is. You have not been told to calculate the efficiency directly. But which of the following machine is most efficient? Yes, the most efficient. And they have given us a mechanical advantage of 2 and velocity ratio of 5. 2 divided by 5 multiplied by 100, that would be 40%. 3 divided by 5 multiplied by 100, that would be what? 60%. 4 divided by 5 multiplied by 100, that would be 80%. You could see. So, and the last one, 5 divided by 4 multiplied by 100%, meaning that the mechanical advantage is 125%. The question says that mechanical advantage can never be greater than 100%. So this option D is not feasible. The larger the air mechanical advantage divided by velocity ratio gives you the highest efficiency. But once it has exceeded 100%, it is not possible. So the correct answer here is 80%. And that's why I've said efficiency can never be more than 100%. Look at this question right now. The question says, which of the following machine is most efficient? You have not, so definitely they are not telling you directly that it's efficiency you are expected to calculate. And once you know that efficiency cannot be greater than 100%, you look for the option that is either lesser or closer to 100%. So let's look at the quick summary before calling it a day. The quick summary talks about work, a certain amount of force applied in direction perpendicular. Energy is the ability to do work, and we have different types of energy: kinetic energy, energy of motion, and potential energy. A typical example, gravitational potential energy, which is the energy of height. Kinetic energy is directly proportional to velocity. As the velocity increases, it also increases. If the velocity increases times 2, the kinetic energy is going to increase times 4. So, the potential energy is directly proportional to the mass. As the mass continues to increase, anybody or object that has more mass will have more potential energy. And power is defined as work divided by time. So let's look at some summary past, some questions on it. Work is said to be done when a force acts without movement. No. Causes displacement. Yes. It must cause displacement. There must be a displacement. The SI unit of energy is what? Joule. The SI unit of energy is joule. The kinetic energy of a 2 kg body moving at 10 meters per second is half times mass times velocity squared. The parameters have been stated. We have mass of 2 kg and we have a moving object of 10 meters per second. So you can actually calculate that. Potential energy depends on what? Height. Power is defined as what? Work divided by time. And work is also force times distance. So if you come across a question that has 3 parameters and you are told to calculate the power, it has a force, it has a distance, and it has time, then calculate the work first, which is force times distance, then divide it by time to give you power. And the SI unit of power is watts. The SI unit of power is watts. I hope you enjoyed today's class. The next topic we'll be addressing sometimes next week will be heat and thermodynamics. For any question, please contact me via this mobile or my personal email address. Thank you for watching.